Hey everybody, CocoaButterCoder here, aka Coco, and welcome to the third episode of the Python Challenge series. If you've watched the intro in the Level 0 episode, thank you, and if you're new, thanks for watching as well. I'll be posting the playlist link in the description to the last two videos. But before I started, I just wanted to say thank you to everyone who's been watching these videos. I started this series because there weren't a lot of people. There were only maybe one or two people on YouTube who were making Python Challenge series, and they're all like years old, incomplete, and I just thought it would be cool to do this, especially during this time, where it's just like there's a lot going on, and this was just something that I was getting a lot of joy from. So I just thought I'd share that, and it's cool to have people watch these videos, and subscribe and everything. It's not my intention to be a YouTuber to make a living out of YouTube, but I'm super thankful that people are choosing to join me on this journey of just like having fun and seeing what we can learn. So just again, thank you so much. That being said, let's jump right into it. So last episode of the Python Challenge, we worked on level 0, and so let me go into that. And this is level 0, the warm-up tab, and I kind of just ran through how these levels are structured, where we get an image or we get a file, or something in the source code that we have to manipulate, and we use the clues given to find the keyword so that we can get to the next level. So for this, we did three things. We realized that this was 2 to the 38, through a variety of methods, using this calc.jpg as a clue, trying 238, and it telling us that the 38 is a little above the 2, trying 2 to the 38, and it's saying that we need the answer. So we're just using clues, consecutive clues, to try to get to that final like key that we need to get to the next level. And so, like I said, we did this 3 ways. One way, we did this in Python interactive mode, and we can just do 2 to the 38, and we get our number. We also did, I think I have the file. Yeah, I should have the file. Level 0.py. Yeah. So then we also did this method of doing it in a for loop. So we have product equals 1 for x in range of 38. Just multiply by 2 and then save that as the new product. We do that 38 times, and then we get the same result as doing it in the terminal. And then there was actually one more that I forgot, which is simple, and it's not different at all. But Python actually has a built-in power function into like Python. You don't have to import a new module like math or anything. It's just right here, as you can see, POW. So we could have also just done, let's comment all of this out, POW 2 and then 38. And if we run this, we get, if this would go away, yeah. Oh, we gotta print it out. So if we do print POW and then we run it again, now we get the same result. So there are just a variety of ways to solve level 0, and I imagine any level, as we'll see with this one. You can see I have a couple tabs here. This is the one we'll be working in today, level 1 youtube.py. This is what I solved it myself. But there's always more than one way to skin a cat, more than one way to solve a problem. So let's just put this number in, put this number into our original level 0 URL, and I forgot the dot. Alright, cool. So I actually have 2 tabs of this open. but just wanted to show the transition. So here, what we have is a notebook, and it says K to M, O to Q, E to G. And with the hint, everybody thinks twice before solving this, and then this like weird text. So like I said last episode, it sometimes helps. No, it oftentimes helps to open the source code and just kind of poke around and see what's there. So I just click Control U, and the title is called "What About Making Trans," and that'll be our last approach to solving this problem. But we have "What About Making Trans," map.jpg, this weird text here, and then some tips that they provide in order to solve these problems. So what I'm going to do is I'm going to copy this text and go back here and go into our level 1 YouTube.py. And I'm just going to call this ciphertext. If you've also checked out the code book playlist that I started, or a series that I started rereading the code book by Simon Singh and decided to try to implement certain algorithms for different ciphers. So if you're interested in that kind of thing, like I'm not an expert in cryptography. Again, this is just something that I enjoyed and something that I was having fun with. So if you're interested in that, still going through like some basic ciphers, some basic monoalphabetic substitutions and transposition type stuff. But yeah, there's also that, and I'll link that in the description as well. But this is just some ciphertext. We don't know what it is. It's just some message. It's all scrambled up. And what happened? Oh, there is probably, yeah, there's a single quote here. So this is an easy fix. We can just change this. We could escape it, but I don't feel like it. Just go into double quotes. And then I'll hit Alt-Z, put it all in one tab. So I'm going to try something new, and at this point I'm going to switch to a paper method. So we're going to switch right now. Okay, so I thought this would be kind of cool because to me, one of the things that, like, when I'm watching, a movie or TV or something, and they show people who, are hacking or coding or whatever, a lot of it happens with a computer. But at least in my experience, whether I'm in class or I'm working on a project or something, a lot of the planning of it doesn't happen on the computer. You have paper, you have a whiteboard or something like that, and I don't really have a whiteboard, so I thought it'd be kind of cool to try to, do it the way that I usually do it, just kind of to show my process. So the big thing here is that we had our K to M, right, and we had our other two letters, and we had this jumbled up text at the bottom. And so if we were just to write out our alphabet, we would get something like this. So A, B, C, D, E, F, G, H, I, J, K, L, M. And if I had planned better, I would have had it all in one line, but I did not. N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So the key here is if we focus on this K, because I'm working on the camera, and so I do not have the tab up right away. But if we're working on this K, right, we hop over 1, and then hop over 2 to the M, because it said K and then the arrow to M. That's two hops. That's 2 spaces. I think another one was like the E to G. So there's 1, 2. This is also 2. Because I don't remember the last one, I'll just pick a random one and go P to R. So this will be 1, 2. So of the 3 pairs of letters that we receive, each one of them with a hop of 2. And so we can kind of just assume from there. There are other techniques we can use to like really be sure, but because this is only level 1, this is still like a basic problem. We can kind of just assume that the whole cipher is just moving whatever the plain text or the original alphabet was 2 spaces over. And now back to the video, or at least the screencast. Okay, so before we get right back to it, props to me because I didn't get all of them right, but I got 2 out of 3. It was O to Q, not P to R, but it still stands. So now that we have our drawing and we know that we're just shifting things over 2, which could be called like a ROT 2, or a Caesar cipher of 2, or a Caesar shift of 2. We can now have a better way to proceed. So I think I have 4 ways to show, maybe 3.5 ways to show how to do this, and it goes from ugly to not ugly. So we can do method 1. Method 1 is going to be the ugliest. So we can do a dictionary, and let's call this, I don't know, cipher dictionary equals empty dictionary. And this is the really ugly one, because it does not utilize the power that we have with programming, and we could just list out every single possibility. So we can just do this and go. Let me get that comma in. And now we have 5. Do this 5 more times. 3, 4, 5. And then we need this 1 more time. Okay. And then we just gotta go down the list. C, D, E, F, G, H, I, J, K, L, M, O, L, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And then we just have to do it on this side as well. And D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, and then it loops back around to A, and then B. So this is easily like the worst way to do this problem, right? We shouldn't be creating, especially something like this where it's like a pattern of 1 letter and then 2 letters down, and then the next key value pair is just add 1 to each, and then add 1 to each time. That's something that we should be able to do programmatically. But if you were like a beginner and you didn't know what to do, this would probably be like maybe a easy way to conceptualize this. So we're just going to make a new variable called plain text. Just make an empty string, and then we're going to do for character in ciphertext. So we're just going to do a for loop and we're going to do plain text plus equals cipher dictionary dot get character, and print out the plain text. And we can run this. Sometimes I get afraid like that I'm not recording, so I have to check every once in a while. Can only concatenate string, not none type. Oh, okay. So let's do for character, and if character and cipher.dictionary, else plain text plus equals character. Yeah, so before I read off what it says, the addition that I made, it was saying before that can only concatenate string, not none type. So this loop works. It's saying for every character in the ciphertext, add to the plain text whatever the value is of the character. So for example, G maps to I. So it's saying get the G value, which is I, and then add that to our plain text. But then we have some characters that aren't letters, like these spaces, these parentheses, that one single quote from earlier, a period. So it was throwing an error because we didn't account for that. So we can do something like if character in cipher dictionary, which is the same thing as if character is in the cipher dictionary keys. Like this is, these two things are equivalent. Dot keys. So either way, it's saying that if it exists in on this left side, then get whatever values on the right side. Otherwise, just put the original value in. And so now we can go back, and it says, I hope you didn't translate it by hand. That's what computers are for. Doing it by hand is inefficient, and that's why this text is so long. Use string.makeTrans is recommended. Now apply on the URL. Okay, so that's ugly method number one. Ugly method number 1.5 is honestly the same. It's just using index instead. So if we do for index in ciphertext, in range of length of ciphertext, and then we have to set it up the same way so we don't get that error thrown about none type concatenation. So if ciphertext at I do this all the time, at index is in cipher dictionary, then plain text plus equals cipher dictionary dot get cipher text at index, else plain text plus equals ciphertext at index. So if we run this, we get the same thing. And honestly, this is why I said it's like, not because the results are the same, that this is a 1.5. The only real difference is, this is why I just erased the original method. So this should be method 1 and 1.5. I just wrote right over. I prefer the original method of doing it because it reads a lot better. It just makes sense. Like, part of the reason I like Python because it can be very readable, very English-like. And this is it's more obscure, it's more like technical, and it doesn't necessarily need to be. So we're gonna go back to our original, and that'll be our methods 1 and 1.5, the really bad way of doing this problem. I'm just going to go back to our character because I like that a lot more. Look how nice that is. Okay, so moving on to our method 2. Get rid of all of this, honestly. So we're going to comment all of this method 1 stuff out, and then go on to method 2. So like I said, the main problem with method 1 is that we as programmers, it'd be one thing. So like, again, if you're interested, I also have a series on like ciphers that I'm working through in the code book, and this particular problem of the Python challenge is a Caesar shift, and it's called a mono-alphabetic substitution. So every letter has a single corresponding unique counterpart, and so it's very easy just to move things down, but they don't have to be that way. You could do something like, A maps to Q, and B maps to D, and E maps to F. Like, you can just be very random about it. And so if it was a random cipher that we were using, then maybe it would make sense to do what we did up here and then like actually write it all out, right? But because there's a structure, there's a pattern, we shouldn't be doing that. So here's method number 2. This is not the make trans, that's our last method. But basically what we have here, we have our ciphertext up top, right? And like, if I was to do this, what you basically want to do is you want to add 2 to every value of the letter so you get the next one. So we can try doing that. We can just do like plain text equals an empty string, and then for character in ciphertext, we're just going to do plain text equals character plus 2. I'm going to do plus equals, and then I'm going to try to print the plain text. So if we run this, we get this problem because it says that can only concatenate string, not int to string. And so the problem is that, one, you can't concatenate integers to strings, but even if we can go there. You can't concatenate strings to integers. These are 2 different types. Character, see it says string, and then 2 is obviously an int. So what you want is to get the value of these characters. And so in order to do that, you use the ORD function, and it says return the Unicode code point for a 1 character string. So we can just run this in ORD, and this will give us something. This problem is probably still because plain text itself is a string. So then we would want to do ORD character that returns the value of the character, then add 2, and then we need to convert that back to a character, so we can use the character function, and we just do all of it, and lucky for me, I already put it in parentheses. And we get bits and pieces, but then there's a further problem to this. So back in when I was writing this out, we have 26 letters, and if we were to count them, we would probably count them 1, 2, 3, etc., all the way to 26. But since we're programmers, we probably do it base 0 and just start with 0 to 25. Still 26 letters. But the bigger problem is that if we open up a new tab and get an ASCII table, this is how especially the letters and most of the symbols, it's not alphabetical but ASCII-betical is how it's referred to in Automate the boring stuff. So A actually has a value of, which one is it? These are all lowercase. So 97, I think. Yep, 97 is lowercase a, and then we get 122 for lowercase z. So we actually have a problem, because if we were to do this by hand, we would know conceptually, okay, if I get to like Y or Z, I need to loop back around. So I need to go Y and then 1, or Z would be 1, and then A would be 2, right? If I go to Z, then it'd be 1, 2. But that's not what our program does. It gets to Y or Z, and then it just goes 1, 2, or 1, 2. Which is why, especially with these spaces and stuff, which we didn't account for, because spaces themselves have their own Unicode value, so going to render something else. So the next step that we have to do here is, one, we need to catch for like if character, not callable, if character is alpha. And I think in the last video I said alphanumeric or something. It shouldn't be alphanumeric, because you don't want the numbers to change the same way you don't want commas to change or something like that. In one of my videos I said that. But if character is alpha, like an alphabet character, then change it. Otherwise, you just want to add whatever the character is. So plain text plus equals character. Run that again, see what we get. So now we don't have these quotes. Mostly the quotes are the biggest problems, maybe like this 0 for the period and stuff. But we're still having an issue here with what is supposed to be an A, mostly the A's. And so the next step is, it's a little cool thing that we can do. So if we do this in a way like ord character, there's no reason for me to erase it, minus ord A, that'll give us the distance, and we can go back to our drawing to kind of visualize this. Okay, so this is what we had for our setup last time, and naturally we just wrote it in lines or whatever. But if we write it like this, we'll just do or probably, oh my gosh, I didn't plan this out. Yeah, that could have been planned a lot better. But if we think of it more in like a clock formation, instead of 20 or 12 hours, we have 26 letters. This kind of gets easier to visualize. So for any letter, we can say that A is 0. So for any letter, what we want to do, H-I-J-K, it's just weird because it's like backwards this way, but it's going this way, just for my own sake. But we can call it A0, and then for any letter that we find, we can calculate the distance from A. So in our ciphertext, the first one is this G. So what we can do is calculate this distance. So this would be 7, because this is 1, 0, 1, 2, 3, 4, 5, 6. So, oh, wait, 0, 1, 2, 3, 4, 5, 6. Yeah, G is the 7th letter, but there are 6 letters in between, right? So this would be a difference equals 6. And then what we want to do is then add 2 to that value. So then we do 1, 2, that gets us I. So if we add 2 equals 8, right? So H-I, I in this case is 8, even though it's the 9th letter of the alphabet. Okay, putting the cap back on this Sharpie for right now. But we've already calculated the distance from our character to A, and then we add 2, like we did in our drawing. And then once we add 2, we want to add the value of oops, not 97, of our lowercase a. We could also add just like a, or not a, just the integer 97. But I was taught like to avoid magic numbers. So even though 97 has a meaning in this case, like it'd probably be better just to use the ord of a in order to be more explicit about it, and then we can convert the whole thing back into a character. So we can try this again. Okay, so it looks the same, but trust me, we're a little bit closer. The problem is we didn't account for our y and our z. So back to the drawing real quick. Okay, so please excuse me for like how messy this is getting, and the fact that I did not plan accordingly, so that it was like a more complete circle. But let's start with y. So y, if we calculated the distance from a, y is going to be 24. So we can just do over here, y equals 24, right? So y minus a is going to equal 24, right? We add 2, we get 26. So that's supposed to be this a right here. So 1, 2. It's supposed to be this a right here. But this isn't like, military time or anything like that. Like, we don't have a 26 here. So what we have to do, and the reason I drew it in a circle and I'm making this analogy to clocks, is because when we get to 12 o'clock and it's, 12:59, and we're not using something like military time, we go back to 1, right? And so here we want to go back to our 0 base index. So we have to use our operator modulus, right? And so this would just say 26 divided by 26, and then what's the remainder? So in this case, we get 26 divided by 26 is 1 with the remainder of 0, right? And, 0 in this case is our a. If we did the same with z, z is 25, and so z equals 25. Z minus a is equals 25. If we add 2, that's 27, right? We don't have a 27 on our thing. It goes 0, 1, 2, etc., all the way to 24, 25, right? So we have our 27. If we mod that, 26, 27 divided by 26 is 1 whole 26 with the remainder of 1, right? And so this 1 is our b. So that will be our next step. So what we're going to do is we're going to modify this accordingly, right? So we have our distance, and we add 2. We need to mod this whole section, excuse me, this whole section here, and that will give us the letter value or the position of the letter, and then we add the original, or not the original, but we add the Unicode value of a, convert that whole thing to a character, and then add it into the plain text. So if we run this, and then my comment came out, hope you didn't translate it by hand. That's what computers are for. Doing it by hand is inefficient, yada yada yada. So that's method 2. The only thing I would change at this section here is that this is kind of getting a little jumbly, so I'll probably do something like this. Distance from a, move this here, maybe even do letter position equals distance from a plus 2. Mod 26. Now I can get rid of all of this. Letter position. And now it's just a little bit more readable. Just try to clean things up. Just getting into the habit of making things kind of tidy for the next person, or like for you guys when I post this stuff on GitHub and things, so that people know because I am pretty bad about commenting, and it's something I need to get better at. But still working on it. And so that's method 2. And then method 3, where it says here, where is it? Oh, string that makes trans is recommended. So I had to look up string that make trans because before this I didn't have much experience with it at all. So if I go to make trans Python, and a couple of these links are purple because I usually do these levels before I start recording, not like the day of, but ahead of time, just so I know what I'm talking about. I don't spread any misinformation or anything incorrect. But make trans is cool because it creates a return table that maps one character from the starting or from the first parameter to a character in the second. So what is actually, in a sense, my feeling is that it's doing what we did in method A, but just not nearly as ugly. And I mentioned before, like, I read Python documentation, but Python documentation is usually good for, like, does this thing that's in my head, already exist? But once you find that it does exist, trying to figure out how to implement it or how it works can be difficult. So I usually have to find, like, some tutorial site or example site like this. But yeah, so what we're going to do is, I know this says that we have to import string, but when I did it, you didn't have to import string. Maybe this is a Python 2 thing, but we can do, let's do a new section, method 3, and I'll just comment all of this out. We'll do translation table equals str dot make trans, and then we just do a b c d e f g h I j k l m n o p q r s t u v w x y z. And then for our second parameter, I'm gonna just copy this substring and do this, and then add on an ab at the end. We could just do print ciphertext dot translate, and then we pass in our translation table. So if we run this, we get the same thing as A C D E F G. Oh, apparently I can't type TUVW. That fix it? Okay. A B C D E F G H I J K L M N O P Q R S T U V W X Y Z H I J K L M N O P Q R S T U V W X Y Z. Okay. And then now we get our original message. So these would be the 3, 3.5, 4, kind of how you like, methods that I wanted to highlight. This is really cool because in a way it's almost like what we were doing in the first, but a little cleaner, not as much unnecessary code, but it gets the same thing accomplished. And I think I would order it as such, as this is not how you should do it. Like, it gets the job done. It's not technically incorrect, but we can just do this part programmatically, and that's what we do in method, where am I circling? In method 2, we do this programmatically. Instead of generating a whole dictionary, it's just not even necessary. We don't even have to generate the dictionary. We just have to define the equation or the cipher of how it works. And then here we are defining like the dictionary, but it's just a little bit cleaner. So the last thing is, now that we have our methods, the methods that I wanted to highlight, it says now apply on the URL. So go back, and it's kind of hard to see because even if I zoom in, it doesn't zoom in on the URL, but it's def map.html, and it doesn't mean the whole URL, which you wouldn't be at fault for thinking, but most of the time these keywords only apply to the whatever comes after the PC slash. So in this case, def slash map.html. It's not always def. I think it changes at some point later on. But here, if we just take this map part, and let's say we do URL snippet equals map, and I don't even think we have to do that, honestly. We can just keep all of this and change the ciphertext to map, and we get OCR, which might not mean much to some people, but if we type in OCR into our URL, we go on to level 2. And that's it for level 1. I just want to say thank you again for everyone who's watched this video. I'm enjoying it. I hope you're enjoying it. I'll make sure to post the code to GitHub, so that if you want to look through it or code along, you can feel free to do so. And if you have a different way of doing it, or you think you have a better way or cleaner way of doing it, feel free to drop a gist in the YouTube comments. I would love to see it. I know that especially in the first video, there was someone who was saying that they're learning, and maybe this will help them advance. If that's what happens, like, that would make me so happy to know that people are using this as a learning tool, as I'm learning as well. So as I said then, let's help each other learn together. So definitely post your code. If you have a different approach, I would love to see it. And thanks again. Everyone stay safe. And I'll see you on Saturday for the Cipher Saturday video. It's called the Kama Sutra Cipher. That's not his actual name, but I'll explain more on Saturday. See you guys.